when you process food and make it shelf stable, you do get rid of the spoilage bacteria and the pathogenic bacteria. So you've eliminated the safety concerns with the food, but you're not stopping the chemical changes that occur in food. And those chemical changes can lead to change in color, change in texture, change in nutritional content. So all of those things are issues that have to be dealt with for ISS, but especially for long duration spaceflight. For a trip to Mars, especially the initial trip to Mars, we're probably looking at 5 years shelf life on the foods that go on that mission, because that initial mission the food will have to be, a lot of it will have to be sent ahead of the crew on an unmanned vehicle. It'll be waiting for them either in orbit or on the surface of Mars. And included in that food will be the food for their return trip, which we know with current propulsion technology will be about 3 years after they leave, roughly. And because the food will have to be sent ahead, then we're probably looking at 4 to 5 years shelf life for the foods that come back on that return trip. And we do have some products that can meet those types of shelf lives, but certainly not enough to support a 2.5 to 3 year mission, and not enough variety of products to give the crew members a balanced diet. So one of the big challenges that we have for that initial trip to Mars is how to come up with enough foods that will meet that type of shelf life. And we also have to look at the nutritional content, because nutritional content in processed foods does degrade over time. And so we have to be sure that we're not going to be in a situation where those crew members are missing some critical nutrient, like, for instance, similar to the vitamin C scurvy issue that occurred for the ocean explorers, years and years ago. We have to make sure that all the vitamins that they need, the critical nutrients, are going to be available throughout their mission for that initial trip to Mars.